Well, welcome. My name is Jones. I'm the director of the Yampa Valley Sustainability Council. This is our February Talking Green. We have some great speakers today talking about passive homes. But before we start with that, I just want to, of course, thank our sponsors and tell you a little bit about what we have coming up. So we could not do Talking Green without our wonderful sponsors, and of course, Kelly. Our other sponsors include All Season New Power Source, Home Lake Magazine, and Resort Group. So we'll talk about. All right. We have some great events coming up. One coming up at the end of February is our SIGA air sealing workshop, April 26th.
Do you want me to talk about it?
Yes, so I want to tell everybody that it's from 12 to 2 at Library Hall.
It's an advanced air sealing workshop. We'll get into air infiltration information on this presentation, but ultimately it's how to achieve extraordinary air sealing objectives when it comes to buildings.
If you want to make sure you get information about that event, we sign up. There are 20 people. It's a limit of 20 people. So you can put your name on our list and put air sealing workshop if you're interested. Yeah.
Is that this instruction or discount?
It can be both. I'll go ahead.
And I'm going to quickly piggyback on that. Why did you get excited about a rebate and incentive plan that we're working on? With YDA, Yampa and also one of the rebates will be for air sealing. So look for that. Probably we'll have more information. We keep saying February, March, but it is coming, and we're really excited. We'll have about $22,000 from the city and YDA to go towards energy efficiency rebates. Everything from audit, air sealing, light bulbs, on and on. So look for more information on that coming. Okay, other upcoming events. We have 3 movies coming up. Food Chains, which is on February 11th. Seeds of Time, which is on March 10th. And Pump, which is about alternative fuels, on March 28th. Those are all, we partner with the library on those events. So they'll all be at Library Hall at 6:30. So you can always find all this information, of course, on our website. And then, of course, a quick selfish plug. The Yampa Valley Sustainability Council is a small nonprofit, and we always encourage or love donations from everybody to keep programs like Talking Green and our other programs going. So there's a jar up there, so whatever you want to do. Okay, so starting on our passive house, I'm going to quickly introduce Todd and Erik. And then we also have Florian, who is with Zola Windows, who will be speaking after about energy modeling. But we're going to start with these guys. Todd is passive house trained and the founder of AE Building Systems, products for high-performance building. AE Building Systems provides home and building owners, architects, and builders with products, services, and information necessary to achieve high-performance building objectives and critical, including passive house, LEED, ResNet, PERS, Energy Star, etc. So his passion is fueled by the desire to provide home and building owners comfortable, healthy, and highly efficient places to live, work, and play. Erik is a certified passive house professional. This is our local guy. Todd's from the Front Range, just to give you perspective. He is a professional residential designer, energy efficiency nerd, and building science professional located in Lobeck. He strives to design and construct intelligent residential buildings using modern design and efficiency with local flavor. He presides over Workshop L. And one of Erik's houses was on our green building tour 2 years ago. So I don't know if anybody participated in that tour, but you got to see his house on Yampa Valley under construction. And I also wanted to do a quick plug for Home Lake. Home Lake is, Josh isn't here, but it's a great magazine that features sustainable building and living. And I don't know if Erik has anything in there, but there's some great resources. You can also go online. I know it has within an article in Homeland, so you can always go to Homeland, and they have all their past issues online. So thank you, and let's have fun.
Before we get started, it'd be interesting to know who's here. Is there architects that are in the audience? Architects, builders, homeowners that are just energy geeks and super interested in this kind of stuff. Other audience? Yes, people are just here to drink.
Mechanical contractors?
Mechanical contractor, okay. Mechanical contractors? Okay, great. Is that Finn's fans? Finn's got it.
But thanks for remembering.
Yeah. My name's Todd. As Sarah mentioned, I'm with E Building Systems. I started the company as a result of taking the Passive House training with the intent of figuring out where I could fill a hole. My actual training from undergrad is computer science, so I have a technical aptitude. But when it comes to the building industry, I had an interest in doing architecture, but didn't. And it was probably more lucrative to do computer science at the time. All said and done, it's always been in the back of my mind. So I've always been interested in the building industry and specifically the high performance industry, passive solar design. Back when I was interested in doing architecture. So in the process of taking the training, I was looking for holes that I could fill. One was modeling, doing energy modeling, and Florian's going to talk about that today. And I was a computer science guy, so I knew I didn't want to do the modeling because it's sitting in front of a computer doing, anyway, it wasn't the right fit. So I found that products were a tough component of Passive House because ultimately we don't have them to do a really high performance, energy efficient building. They're hard to find. So I assembled a set of products that work together really well. So that's the history of how I ended up in this industry. We've been going for 3 years and things are going really well. People are really tuning into this industry. Obviously, we got probably the better part of 70 people here, which is exciting. Thank you all for coming. So to give a little bit, yes?
Will this PowerPoint be something we can get copies of?
Yeah.
This will be posted, both the video and the slides will be on our website. So we'll probably take a day to get it off the page.
So to give you some history, passive house, Florian, how would you say it? Where's Florian?
In the back.
Passive house? Passive house is a literal translation. It actually means passive place of inhabitation, ultimately. So it applies to not only homes but others, and I'll go into that later. But actually it started here, ultimately. Wolfgang Feist, Dr. Wolfgang Feist, is a professor of physics in Germany, and he came to the United States to study some buildings. Buildings to include passive solar buildings, super insulated buildings, and there were problems with them. Passive solar, we get overheating. It's called massing glass a lot of times. A lot of glass on your south-facing facade. If you don't have good overhangs, you end up getting overheating in your shoulder seasons especially. Also, the glass back in the 70s wasn't good. So Wolfgang Feist came over to the United States during the energy crisis of the 70s, and he's like, okay, we need to figure out how to do things better in Germany. So we had significant losses at night because the glass was poor. It wasn't performing well at night. So you have great gains during the daytime, but great losses at night. And then we have super insulation. Super insulation are like thick walls, double-studded walls with lots of insulation and a thermal break in them. But what he found was some of them were failing. They were failing because there was air getting into the wall timber. With that air comes vapor or moisture. That moisture then, like a cold glass on a hot summer day, will sweat on the outside. So will happen with your interior walls. So if you got air bringing vapor into the wall assembly, moisture will collect on the cold surface within the wall assembly, and if it can't dry out, it will cause moisture and rot. So some of the problems, and if you want to chime in at this point, we've got a more forgiving climate here in Colorado. It dries quite readily. And Erik was going to argue with me.
No. I live in a house that has
Moisture
lots
and rot?
of moisture and potential for rot.
Okay. So he brought this information back to Germany, and he put together eventually a standard. It took him a while. It wasn't until 1991 that he put together a standard. And that standard included a lot of different variables. And the next slide actually goes into the primary objectives of passive house, but ultimately we want an airtight assembly, because if we're not letting air into the wall assembly, then we're not letting vapor or moisture into it either. So we want an airtight assembly, but also we lose approximately 30 to 40% of our heat through air infiltration. So if we can make our wall assemblies airtight, then we're not losing nearly as much heat in the summer, and the front range is more relevant, not necessarily up here as much, but we lose less cooling. And then secondly, and this gets into the passive solar design, it's not necessarily a function of maximizing your south-facing glazing, but more optimizing your south-facing glazing, but also paying attention to the elevations. So on your west side, so you don't overheat in the summertime, you want a lower solar heat gain. So you want to pay attention to how to optimize the glazing such that you're not overheating in the summer and the shoulder season, but also maximizing your solar heat gain in the winter, but also not not too much. It's not a function of maximizing the glazing, but maximizing the impact of the glazing. And then compact shape is really a function of volume to surface to volume ratio. Does everybody understand? If you've got a shoebox or cube, or instead of, say, an L-shaped building will have a lot more surface area to your volume, because you've got a lot more wall space, your exterior wall space, versus a cube. And it's really important to pay attention to the fact that if you're creating bump outs, for example, you're increasing your surface area.
Or like we do in steamboat roof line, do this, and go back, and our gables glue together, that kind of thing.
Right. So if you can create more of a cube, it doesn't mean that we can't have bump outs or we can't have an L-shaped building, but it means doing it with a purpose, not necessarily doing it for the sake of doing it. Yeah.
Hey, guys, there's probably some more seats in the back. I don't know if it's hard for you to see, but if you want to, I just saw a couple come on in.
No worries, no worries. So 4 and 5 are kind of combined. Continuous insulation and minimizing thermal bridging. So if you have a continuous blanket around your building, it's better than having thermal bridges. So for example, a cantilever balcony or other thermal bridges, 2x4s, 2x6s, 2x8s, whatever they are also thermal bridges. If you take a thermal image of a building, when it's cold outside, you can see the 2x4s in the building. And if you can minimize the thermal bridges and create a continuous insulation barrier around the entire building, that's better than not having them. One of the things that we learned right off the bat is, first, you draw a line around the conditioned space, and that first line is your air barrier. You want to make sure it's airtight. The second line is your thermal barrier. It's a function of making sure you've got a thermal barrier and an air barrier.
He's serious about it. You can see the look on his face.
And then one of the things that we don't necessarily have readily available here in the United States is high-performance windows. Our windows, historically and generally made by a U.S. manufacturers are not as high-performance as they are in Europe. The fenestration industry in Europe is way ahead of us in general. not entirely, but in general. So high performance windows with great view values, but also low air infiltration is extremely important. And then finally, when you have an airtight assembly, an airtight building, you have to bring in fresh air because you're no longer getting it through all the holes and cracks in your walls and so you've got to bring fresh air in. Balanced ventilation is the next important step. But the nice thing about passive house, in some of the technology around passive house, is there's HRVs and ERVs. What that stands for is energy recovery ventilation and heat recovery ventilation. So not only are you bringing in fresh air, you're taking out stale air, bringing in fresh air, but you're transferring the heat to that incoming airstream. So you're not losing your heat that you paid dearly to generate. So, but also you're controlling the quality of the air because most good ERV systems also have great filtration systems. So, for example, a product that we carry has got a MERV 12 filter. MERV 12 is one step below hospital grade or HEPA filter. So you're getting high quality fresh air back into the building.
And that's a key component. I mean, you can't just build a tight envelope that's air sealed and well insulated and expect the air to somehow find its way in. That can cause problems, or it comes in through, say, the crawl space where dust mites and spiders are happy to, contribute to your air quality. So that's a pretty key component of the system.
My voice travels really well. Is everybody hearing me? But also, am I screaming at you? Okay, good.
Well, good.
Okay, good. So, the ultimate goal with passive house is to reduce the energy required for heating by 90 to 95%. We're in heating climates. If we're in New Orleans, it'd be the energy required for cooling. So, the energy required for heating by 90 to 95%. The fundamental objective or requirement to meet passive house certification, there are two primary objectives, is 4.75 kBTUs per square foot per year. Okay, what does that mean? General house uses 10 times that. That's 4,750 BTUs per square foot per year. So multiply by 10 is what a basic house in the U.S. would use. In steamboat, it's hard to reach the objective because we're in climate zone 7. So what Passive House Institute U.S. is doing is they're creating a climate-specific requirement, which is going to be different than this 4.75.
It's not to say that it's not possible, but I mean,
It's
one of those
next to
questions.
impossible.
It's one of those questions of how much money do you want to throw at the problem. And right now, just to give it, shed a little bit of reality on that somewhat abstract number, they're heating their house with basically a 2,000 watt blow dryer. That's what it comes down to. And you could overheat if you throw a party.
Yeah, get open the window. You have this many people in the building, it's going to be hot. So, similarly in a southern climate, this is a secondary requirement. If you can't reach this, it's a possibility of doing total energy, 38 TBQs. But the other primary requirement is the airtightness. And this is the tough one. It scares the builders. The reason it scares the builders is because 2012 code has just required 3.0 ACH50. Woo-hoo! 0.6 ACH50 is extremely difficult to get to, and it requires an extreme attention to detail. Do you want to expand on that?
It requires attention to detail, but I don't think it's
Impossible.
outside the realm of a lot of our highly qualified builders here who actually care about building an energy efficient home. I think it's attainable, and I think it's a collaborative effort between the designers who are designing the house to make something, the detail that's air sealing. I'm looking at the numbers. That is also constructible, that's executable in the field without too much of an issue, and that's where some of these products, like these air sealing tapes, come in.
To give you some examples, houses built in the 70s are likely closer to 11, 12 AC H50. So we're talking 20 times worse. Houses built in the last 5 years are probably 2 to 7 ECH50, so as much as 10 times worse. 2012 code requires 3.0. A good builder generally setting 1 to 2. 0.6 is tough. So it's the reasons for passive house are much greater than comfort, but we're going to talk about comfort in a second. You will think it's a function of the fact that in Germany energy prices are 3x. They're 3 times what we're paying here, twice what they're paying on the East Coast. But also there's the global warming conversation. There's the environment conversation. But when it comes to the fundamental client, and if we're going to grow this market and make people interested in it, we have to be beyond the global warming. We have to be beyond energy savings, because some people have more money than God. So when it comes to what it means when you're standing in the room, the living room of a passive house, is comfort. And it's really a function of the wall surface temperature. There's 2 things that are going on when you feel uncomfortable in a building. One is your body it's warm. So the wall here is cold, and it's literally, heat travels to cold. Hot air does what? Rises. Heat, though, travels to cold. So if this wall is cold, it's sucking the heat off my body, and it's making me feel cold. The other thing is we've got a warm wall, because that's next to another, I think it's next to another building. That's a warm wall, and that's a cold wall, and what's happening is you're creating a convection current right in the room. Because what's happening is this is dropping. These cold windows are dropping. And literally we'll get a convection current right in the room. You'll feel cold as a result of the fact that this cold air is rushing this way and this warm air is rushing that way. And so we've got 2 functions of discomfort. Generally, when that starts is when there's a passive house would say a 4-degree temperature difference. So ambient air temperature is 68, your wall surface temperature is 64, you start feeling discomfort at that point.
Sorry, can I?
Yeah.
Who, just to satisfy my own curiosity, but who here lives in a house where there's, say, perhaps a window wall next to a space where they hang out most of the time in the evening on a cold night and feel cold next to that space because of convective currents or cold glass or similar? It seems to be a recurring problem, and I'm just sort of verifying my own. Okay, yeah.
Right.
That's what this gets at.
Right. So passive house would say a 64-degree surface temperature. At that point, you're comfortable. And one of the things that we found from our clients is that they're so comfortable they have no idea how cold it is outside. One, for 2 reasons actually. One is they're not feeling that radiation or those convection currents. But 2, they can't hear jack squat outside because the windows are really good and the walls are really thick and they're very insulative. And it might be blowing like hell outside, and they have no idea how cold it is. Would you say your clients would say that?
I would say they would vouch for that.
They vouch for that, yeah.
I think the noise cancellation is a side effect of this methodology that
It's an added benefit.
has some merit.
Yeah. So when it comes to how much it costs, in Europe, generally it's a 3 to 5% incremental cost to build a passive house. And that's partially because of 2 reasons. One, their code's already more stringent than ours is. But 2 is they've been doing it since 91. So there's a lot more people that are in tune with what it takes. And they're trained and they know how to build it, bid it, They know how to do it, so they don't have reservations about, bidding it. I don't know how many HVAC contractors that have told me, I'm not touching that project. There's no way that's 14.5 kBTUs per square foot. Peak load, which means very low. And they're trying to do a one-hole geothermal system, which is really aggressive. All said and done, there are, as people get in tune with passive house in the United States, the costs will come down because there won't be as many unknowns. But what this graph gets at is our investment, cost to build, versus our energy costs. So our energy costs, I gotta use this. Our energy costs, as the energy cost goes up to operate the building, the cost is much lower to build it, right? So there's a point where our HVAC system doesn't necessarily need to be a traditional HVAC system. We can go with smaller HVAC systems that are significantly smaller. In the Front Range, easier to go to a mini split system in an ERB and call it good. Here it's a little bit tougher because you're colder and the mini splits don't necessarily cover our costs, our heat loads during the really cold times. So this actually may not necessarily apply as much in Steamboat, but in Germany, they're in climate zone 4. So it's a very relevant, and in the Front Range, it's a very relevant. Our HVAC all of a sudden goes away. There's a couple in South Denver, they don't have furnace. They have a couple of space heaters and an ERV. Energy recovery ventilation system. And that's all they have, and they're fine. They're thinking about putting a mini split in because they need some air conditioning in the summer. It's hot enough. But they don't have a furnace. And the building code guys were like, seriously? You want to do that? We're fine, but you need to sign this document. But seriously, and they actually have Florian's windows.
What's a mini split?
A mini split is something you'll find very frequently in Europe, and you'll find in Asia, you'll find everywhere but here. It's a heat pump. It's an air-to-air heat pump. And there's a compressor outside, and there's a head. You might have seen these wall systems that are wide and not very tall. That's a mini split. Who hasn't seen one of those? Okay. So on your roof, outside your back door, you might have this compressor similar to a heat pump that you would use for heating and cooling a normal house. And on the inside is a head that actually does the heat conversion and blows hot air in or cool air in. But it's relatively small, and they call it a head. How would you explain this?
It's called a head. Basically, it's a fancier version of a home air conditioning system that can heat as well as cool. It just operates by allocating heat from areas of high heat to low heat and vice versa if you flip the switch.
But it's using heat pump technology similar to a refrigerator.
Pretty much.
Mostly what you see in hotel rooms, right?
Yes. Oh, no. Not always. Not always. Sometimes.
That's the ones I can afford.
It's just hot and cold. It's a package.
Yes, but what's at the hotel isn't always a mini split, and very infrequently actually so.
I'd like to just go into this little dippy thing on the curve a little bit more. Sort of the passive house ideal, sort of the mantra behind passive house is that a lot of this money you're spending on your building is perhaps spent on insulation. And then you're dropping out the mechanical system, so you're taking that money instead and allocating it towards your insulation. So you're kind of taking away something that's technically complex and substituting a dumb system, which I call insulation, because it just kind of hangs out at the wall with minimal maintenance. And that's sort of the fundamental premise of passive house, is taking out mechanical stuff and
I.e. passive.
yeah, it's passive. It kind of fades into the background. That's where that term comes from, not passive solar.
Erik, I think when you were building, we talked about this kind of, the whole thing we combat with, it's gonna cost a lot more money. And I think if you can show the ROI, which is pretty quick, I think, on your energy costs and savings.
In this climate, it's pretty hard to prove a point strictly on ROI. I think it is a two-sided argument. I think it's comfort and ROI over the long term.
Okay, that's part of the challenge.
Yes.
Is that it's so much more to build this way, even if you took it down a notch. I think that the costs are coming down.
Yes.
I don't know, you guys can speak to it more, but
No, that's a good
it
point.
seems to be a point that I have to often,
It's going to take a while before the costs come down a whole lot because there's still a lot of education.
on this particular side.
Yeah. Now, there's another product called DGH, which is a darn good house.
We'll get it.
Yeah. So there's a couple of misnomers about passive house. House is in the name. And it's, again, it's a literal translation from Haus in Germany, and that means place of inhabitation. So passive house isn't just a standard for residential construction, single-family residential construction. There are plenty of multifamily projects. In fact, there's 3 that are in the certification process here in the United States right now. Schools, one of the first passive houses is a small German school in Minnesota that was done right here in the U.S. Lots of schools in Europe that have been built to the passive house standard. This building has recently been completed. It's in Austria, and it's a 20-story office building certified by the German Passive House Institute. So it's not just a standard for single-family residences. Please remember that, because the passive house thing, they've been dealing with how to figure out how to take it to market with the commercial world, and it's not just for commercial. But also, it doesn't have to be ugly. A lot of people, also, one of the other misnomers is everybody says, "Can you open the windows?" Of course you can. Of course you can. In fact, it's important to open the windows in the summertime. But this house was a passive house built in, it's in D.C. This is a more modern structure in Minnesota called Passive House in the Woods. Look it up. The guy doesn't have a furnace. He has some electric resistance in the building, and that's about it. I really like this one, Dennis Wedlick out of New York. This is Hudson Valley, New York. They use sits on this, and they use this timber frame system that they pulled up like whale's ribs. It's timber frame that they literally had a bunch of guys pulling on a rope to pull up the timber frames, and then they finished it off with sits all the way around. And it is one of the tightest buildings in the, I think, in the world.
0.12.
Yeah, as far as air infiltration. So 0.6, 0.12 is what he achieved on his air infiltration, which is like you can hold water in it.
We built a house in North Route in 09 and 010, and we had Chad Fiegler from Mountain Energy do a blower door test, and we're 0.07.
That's great.
So I mean,
0.07?
0.07, roughly.
In ACH or ACH 50?
ACH 50, 3,300 square feet. Brad Bartels was our builder, and Chad Fiegler did all the energy on it, and we blew a blower door test at 0.07 ACH. It's 10 times approximately tighter than the passive house requirement. So I'm here to tell you that it's doable.
You can hold water in that.
It's got a ventilation.
Like a goldfish. Better have ventilation. This is a multifamily in, I believe it's Oregon. I'm not as big a fan as on the design on this one, but it's been widely celebrated, I believe, because it was reasonably low cost. Now, as far as the cost, I forgot to mention this. There was a project in Maine that was built to $130 a square foot, which is relatively low. Again, very shoebox, modified shed roof, very simple construction, low cost finishes, but also met the certification. So it is possible, and it was in Maine where it's a lot colder. So you can do passive house at a cost-effective price point. Another project in Colorado in the Front Range was at $150 a square foot called Posse Vista, done by Cody Farmer, and it's not certified yet, but it's in the process. And it was reasonably sized, again, shoebox design, very simple, and yeah, the $150. He did get some donated products. I argue on the $250 or $150 a little bit, and then of course, all right, Diagon Alley.
Yep, that's actually the name of the street.
And this is Erik Lobeck, and he built Diagon Alley here in Steamboat, and I'm going to give you, thank you for your time.
Hey, before we change, can I have a question here?
Yeah.
You said Germany is 3 to 5% more to build. How about the U.S.?
Oh, generally,
Depends on the climate.
Okay, steamboat.
it's going to be hard to actually make the certification work here in general. There's a guy in Alaska, I mean, you climate zone 7, there's a guy in Alaska named Thorsten Troop, and he hasn't been able to actually meet the certification. He's done backflips trying to make it work in Alaska in climate zone 7 and 8, and he's not been able to. So
It is possible, however.
okay.
So this is an infinite number? What you know?
Generally, in more temperate climates, meaning the Front Range, you can do it anywhere from a 5 to 20%. Florian, would you say 5 to 20% is fair?
Yeah, and I mean, it's possible in Steamboat if you have some solar exposure, which I think that was the problem of Diagon Alley. So
Having a greenfield site with good solar exposure is critical, and the other thing fighting the standard here is the small size. So there's a small house penalty involved with passive house design. In other words, there's a sweet spot in terms of how the engineering and the calculations work out, where 1,200 square feet to around 3,000, 3,500 square feet is a good size for a passive house. This one is on the small side. It goes back to the surface to volume thing. There's a lot of surface area for a relatively small volume.
To expand on that, actually with multifamily, it's a lot bigger multifamily projects with shared walls. You've got more interior volume per exterior surface area with a big multifamily project. So multifamily is actually quite a lot easier to achieve passive house than it is for especially really small volume projects.
And the finances actually work out better on multifamily also if you start thinking about shared mechanical systems, because the individual loads and all the units are lower. All of a sudden, what would be one boiler heating an apartment, instead that one boiler can heat 6 or 7 apartments. So you diffuse the cost of one mechanical system over multiple units. So there's actually a lot to be said for multifamily in this climate. But nevertheless, people still like single-family homes, so let's talk about that. Maybe it's because we don't build multifamily in this country like they do in Europe. In other words, a lot of our walls are paper thin, and you hear the neighbors, and you're always in each other's space. I think that comes down to design quite a bit, thickening walls in key areas so you don't have a sound transmission through the walls and that kind of thing. But it's another topic entirely. So this was a sort of a test bed for my firm, Workshop L, design build firm here in town, really trying out some of the techniques in regards to the passive house. It was a secondary unit, so its size limited to 650 square feet. And I guess ultimately I wanted to try out some of these newer, quote-unquote, newer to us here in Steamboat techniques on myself and on my home rather than on someone else's project. I just didn't feel right about that. So, I mean, there are things that have been tried on this house that are common in Maine, but not necessarily Steamboat, like a shallow frost-protected foundation built on 12 inches of foam. There's no concrete.
Everybody knows a shallow frost-protected foundation.
Yeah. There's no concrete touching the dirt anywhere in this house, so I've completely isolated the interior, the foundation walls and the interior slab from the surrounding soil. And it goes on with a few other things, but let me just keep going. The hope was to create an attractive, low-maintenance rental unit and for myself, and again, trying to take out things that cause problems, like the boiler always breaks. You know, what did I say here? Saturday night at 3 a.m. and chances are I'm in Moab or something, and I have to deal with it. So I wanted to avoid that by removing the mechanicals, anything that just really has any complexity, and I did achieve that. And then second, like I said before, it's a test bed for advanced building techniques, and again, I'm experimenting on myself. And it was an appropriate scale, 650 square feet, to the point where I wasn't building a 5,000 square foot house with entirely untested methodology. This is, so I call it fighting the good fight. Took quite a bit of planning and energy modeling renditions. I probably did about 20 energy models, depending on how I moved things and elements on the building around. A lot of it was design optimization, trying to achieve the passive house standard. This is sort of the ideal, this is a cartoon that I like to throw up. I've used it before, some of you may be familiar with it, but in the 19th century, you know, you had the fireplace and a sweater, you were good when it was cold out. You know, and then we got the 20th century, we like to have all these systems, yeah, some people, you know, it's like showing off the systems, you know, this that does that, and that does that, and a pump here that moves this water from here. And then the 21st century ideal for me, myself, and that I like to try to convey is having a good solid insulation, and then investing the money in the building enclosure and minimizing all this mechanical complexity to the bare minimum that's required, so that less things go wrong.
I had an architect tell me recently, he goes, "What are we, Neanderthals? We're still burning shit in our houses." i.e. natural gas and wood and, anyway, sorry for the flagrant language.
He's a fan.
Oh yeah.
So the conclusions some of the conclusions I came to about the design phase, I have a severe solar orientation penalty. It's urban infill in Old Town. There's all kinds of stuff blocking the ideal southern exposure. The plat of the lot is laid out in exactly the wrong direction for maximizing solar exposure. In other words, it's stretched out in the north-south direction, so I don't have the long direction facing south, which actually changes in other parts of town. So I had that going against me. So that and the small house penalty, which I already talked about a little bit, and it is really a tough climate too. I mean, we're in the same climate zone as Alaska, which always surprises me sometimes, but altitude makes a difference. But I decided to keep going forward with the whole process, and I'm double the passive house standard on that project, and I'm still going for it. I'm calling it the damn good house, it's the DGH Standard, and I'm still focusing on spending the money on the building envelope rather than mechanical infrastructure. I'm a firm believer in that. I mean, just on that house, I have 8 inches of foam on the outside of the entire building enclosure, and then stud-fill insulation on the inside, yielding an approximate, I can't remember what the exact numbers are anymore, but it was like an R50 walls with R100 loaded in the roof, and then R30 below the slab, and pretty meticulous air sealing. In terms of what worked, the super insulated envelope, I really took to heart with the research they've done in Alaska, and I would highly recommend anybody planning on building an energy efficient home look at the Cold Climate Housing Research Center website. Based in Alaska, they actually build test walls and see how they perform, see where moisture is a concern, where it's not. They're a great resource. I mean, they're energy geeks, and they engineer everything, so it's all about data. I like their process. They have no feelings without data, and they were fairly rigorous in their approach. And again, what worked, I think the reduction of mechanical systems and having redundant systems is also nice. So the heat source for that house is low BTU gas fireplace with electric baseboard and tile mats there to supplement and or act as backup. Both of which I think are fairly reliable systems long term. And I think you can actually get away in this climate with electric resistance heat and a well-insulated envelope. It's not like having a condo in Ski Times Square with no insulation in the walls and leaks like crazy, and it's a $350 electric bill.
And speaking of, there is a retrofit standard for buildings to make existing buildings better. It's less rigorous, but also still very rigorous.
Yeah, I think that's important because we have a lot of buildings that we want to make better, and there are systems in place and qualified people to make them better.
I only had a client recently that said, my house is cold. I've been living in it for so many years, and I want to be able to sit in my breakfast nook and have breakfast without a parka on. And, you know, they increased the performance of their windows. They took their siding off, air sealed the heck out of the exterior, put some more insulation on it, and then re-sided it. And their house is now livable. So it's not just an option for new construction, so it's important to remember that.
Yeah. And then what didn't work? The attached garage of the design is a weak link. There's code required 20-minute door between the garage, and even though it's insulated, it only has really this much insulation in it, you know, and over-insulating it is difficult because, well, you know, the doors swing, the door jams, so ultimately I should have placed an outdoor door with some kind of fire rating in that location. That's something, or separate the garage entirely from the house, and I think the house would perform much better without the attached garage. And then the kitchen vent hood and the dryer vent, those are weak links. I mean, you talk about air changes per hour. Depends if you have those holes plugged during your test or if they're open. The vent hood makes a huge difference. In the passive house, in passive houses that are certified in cold climates, generally they use recirculating vent hoods, so you avoid that hole, and condensing dryers. And there's some technology that is maybe...
Has anybody heard of a condensing dryer? Okay, so ultimately there is no vent to the exterior. I've heard the same. Basically what it does is it condenses the moisture within the dryer and sends the water out through a standard drain line. Now the clothes feel a little bit damp when they come out, but they also take forever to dry the clothes. But there is no vent, there's no thermal bridge, there's no potential for losses. I mean, you don't have a vent to the exterior, so you're not losing all that heat from your dryer.
It's terribly important to vent your kitchen hood, and it's really important to vent your dryer to the outside.
Not necessarily.
Point source ventilation. Obviously, if you're a vegetarian and you're just steaming water, you could probably a recycling hood. I'm serious as a heart attack. But if you're not in a super insulated house, if you're not venting your hood to the outside, you're going to smell bacon for weeks.
Well, we can argue about this for hours. So.
Well, it's not an argument.
No. If you have an ERV that has an exhaust or return in your kitchen and you have a booster switch, you can boost the ERV up to max, which is 200 CFM or more potentially, and you're pulling that air out and sending it out of the house.
You're changing the air. The solution to pollution is dilution. Essentially, is what the oil companies say when they spill oil.
Right. So the ERV is taking the polluted air out.
Point source ventilation will purge that odor instantaneously. And there are ways to take care of these thermal bridges too. And I've been working on it as we develop through some of these houses. So whatever. I don't want to distract the conversation.
No worries. That's a good argument.
I'm sort of in between. In other words, on this house particularly, I wanted a venting hood and I wanted a venting dryer because I've read about some of these concerns with the condensing dryers without a vent. However, there are some technologies now. I think companies are seeing the writing on the wall with some of this stuff, and they're starting to attack some of these issues in terms of their product development cycles. There are now heat pump dryers. Things are moving forward, not as fast as we might want them, but they are moving forward. And this is sort of a, yep.
Isn't there a way to use the exhausting air to preheat the air that's coming in, the fresh air?
In terms of the ventilation of the house,
Well, if you're ventilating your kitchen or your bathroom,
Yep.
isn't there a way to use that exhaust air to preheat the fresh air coming in?
and that's what this box called the HRV or the ERV, the energy recovery ventilator that ventilates your house does. It's basically like a radiator that
It's a heat transfer
Yeah.
mechanism rather than a preheat mechanism.
We have balanced heat recovery ventilation in our house, and it works very well, but we still have a huge CFM fan in the kitchen vent, remote fan. Are there any systems being constructed that actually put the heat recovery in gas?
Not that I know of.
Gas. Well, that's a shame.
Well, the mechanical codes are somewhat add-on to that, and I tend to agree. In other words, it's grease-laden air, and even with the filter, you still have some grease particles that could have the potential to clog up that
So
air
that
exchange
would
filter.
clog up the...
Florian, do you know of any?
What?
Florian, do you know of any?
Or no.
Specific for a
This
kitchen
is a
problem?
recurring theme in
They do not have anything out there for that exact reason that we don't know what the customer's cooking. Is he frying up bacon every
Right,
night?
right.
And
That
most
would
luxury
clog.
homes we supply to essentially have an electronically controlled damper, and it's the weak part of the
Exactly.
it's the weak part of the air tightness envelope. But then just make the rest of the house 0.06 and have some budget left for this one.
Yeah. I'm in agreement. Ultimately, if you look at the time that vent hood is on, I mean, unless you're an avid cook cooking 3 meals, I mean, really using it all the time, it's not really...
Cooking 3 stinky meals in it.
Bacon, 3 bacon per each meal.
Yeah.
I hope he makes it through this presentation.
Don't scare him.
Right. So this is sort of for me personally, I'm going with some of my design build projects in terms of the damn good house is what I call it. We've alluded to that before. But it depends on the project and the site. I can't make every house achieve the passive house standard in this climate. There's a happy medium that's unique to every project. It involves budget, it involves the owner's demands. But I keep preaching, trying to simplify the building enclosure to as simple a volume as possible that's easy to air seal and easy to insulate, and then letting design do the work of making it not look like a box. And right now it's falling most of my projects are falling between the 2 extremes of the current energy code and the passive house standard, which is here. And again, there is currently in process a change to climate-specific passive house standards, which makes a lot of sense. I mean, it makes it more attainable for a lot of people. But I take a lot of the things I've learned from building or trying to build passive houses and going through the rigorous educational process in terms of design and energy modeling to really move beyond the current energy code to something that is closer to the ideal.
Well, and one thing important to note is Lobeck is a German name, and Erik's inner German gets the best of him every time.
Yeah. Thanks for pointing that out. And this is one where I've this is a current build project. I mean, it's more modern in flavor than the other one. That's currently nearing completion in the Brooklyn neighborhood. And it's subscribing to the DGH Standard. I'm experimenting with some commercial materials. These are metal panels that are insulated. The metal skin is adhered to the actual foam, and you can get this product in thicknesses from 2 inches to 8 inches. So I'm sort of dipping outside the realm of standard things that are commonly available in the residential building sector or the lumberyard. And same goes with air sealing and subslab foam insulation. And then my favorite pet peeve, garage doors, which is something I'm working on independently because those are a notorious weak link. But on this project, we had to have it here for site design reasons, and that's where it is. But it is a very low-load house, which is good. And it's very comfortable. I mean, right now it just has construction heat on in it, which is only probably about 25% of the surface area, and it's overly warm even on the few cold days we had this year.
Cost per square foot?
This one is about $220.
We started for 2016, maybe.
220, 221, whatever it takes.
220.50. That's all I really have. I mean,
I wanted to share some anecdotal stuff. During the, it's beyond this.
good.
During the vortex last year, there's a builder in Boulder that, I'm going to step back. There's more that comes with a passive house than just energy efficiency, comfort. There's also durability, health, peace of mind, and this is where I'm going with this. Health being, you've got the ventilation system that's filtering your incoming air, so you've got cleaner air coming into your house. It's not going through your walls and bringing in dust. The peace of mind, and there's also risk mitigation. So the peace of mind is one of our clients built a house in Boulder, and he was finishing it up last winter, and the vortex hit, and he had it all buttoned up. It was airtight. He had done a blower door, preliminary blower door on it, and it was 1.0 before he had his finishes on, exterior or interior. And it was below zero for several days during the night, and this is even in Boulder. I mean, up here it's worse. In the house never went below 51 degrees without a furnace. The furnace wasn't installed yet. He had a small space heater that he set on half medium because he only had a temporary circuit for his construction, and he was afraid he was going to blow the circuit. So he had like a 20 amp circuit. So he put it on medium and was hoping that his pipes wouldn't freeze, but the house never went below 51 degrees. So there were pipes blowing all over the front range during that time. And his house didn't even have a furnace, and he was fine. I mean, that's a peace of mind. The risk mitigation that I mentioned is we've found that a lot of our clients are soon-to-be or recent retirees. And their concern is that they don't want the spike in energy prices, which in my mind is guaranteed to happen at some point. I'm not sure when. Some are saying we got enough energy for the next 100 years. Well, my kids will be alive, my kids' kids will be alive then. But eventually we're going to have an energy price spike, and somebody that's in their retirement years and on a fixed income, it's kind of important that an energy price spike doesn't impact their lifestyle during their retirement years. So, we're finding that is a group of people that really want to mitigate the risk of energy costs and make sure that they're leveled out. Even if the next door neighbor is doing this, they're doing this when it comes to their prices. Others? Anecdotal?
The peace of mind thing, I think, is pretty large. There's a passive house school in Montana, and the heat went out, and nobody realized it for weeks, and this was in the middle of winter. Because they had all these little heaters running around during the day.
Human bodies. And that's another thing, in the modeling, and Florian might be touching on this next, but in the modeling they take into consideration how many people are living in the building, because a body at rest actually puts out 450 BTUs. If you're doing vigorous activity, it's over 2,000 BTUs, which isn't a ton. I mean, it isn't, but it's really not that not that much, because typical houses use 70,000, 80,000 BTUs. But they actually take into consideration how many people are living in the building. And they also take into consideration the appliances in the building.
Electronic devices, iPads.
Exactly.
Laptops.
Because they're all putting out heat. That's how
it goes into the passive house design spreadsheet.
That's how temperamental a passive
30 pages long.
Yes.
So on the comfort end, we've been kind of getting our clients to enjoy warm floors in this particular area. Do you have a solution for that if it's not hydronic system? Do you have an air system for that?
He and I would argue on this. Well, go ahead. I would just say that
that the envelope would have to be very well insulated. Get away with strictly space heat through the ductwork system tied to the HRV. That's the European thinking to do that in climates other than ours.
Climate zone.
Climate zone 4. Here, I think it makes sense. Just to put it somewhat into perspective, I mean, if you cut your air changes per hour in your envelope from, say, 2 to 0.5, you can almost take away half a boiler. That's how significant air sealing is to building performance. I mean, you can now go with the model that costs less and is less oversized for the house than a typical system installed by a plumber. That they don't know what the builder has done in terms of the envelope, so the system is oversized. Or you can optimize the system. The spreadsheet allows you, or the passive house system allows you to say, okay, I have a 15,000 BTU fireplace. I'm going to design my whole envelope around using just that fireplace. And I won't need a boiler. So that's all possible within this system.
Reverse engineering.
Yeah, it's reverse engineering. You're thinking about your heat source first, and then sort of the house design follows, rather than saying, kerplunk, here's my house design with all these corners and everything, and now what kind of heating system do I need to get it to work?
Well, the interesting thing is, and Mike, argue with me on this, but manual J generally, pardon?
Discuss,
right. Generally, the manual J overshoots. The manual J is the standard energy modeling system used to determine the size of a system. And often it overshoots by 20 to 40%. And then often bad HVAC guys will overshoot even another 20 or 40%. So now you've got a system that's nearly double the size that it needs to be. And it's oversized. And what happens when they do that is it starts short cycling, and it dies in half the time it should, because it's short cycling. It's like driving a car in the city versus on the highway. You're going faster, you're slowing down. You're going faster, you're slowing down. You're going faster, you're slowing down on the highway. You can get 400,000 miles out of a car. When you're in the city over and over, you get less miles out of your car. Same with your furnace. If you oversize it, it's blowing like hell and then it stops. And it's blowing like hell and it stops. I mean, would you agree with that?
Oh, you're 100% right.
Okay.
For the record, I've been doing my own manual J since the mid-90s.
Perfect.
And installing ventilation systems in houses for the mid-90s.
Yay!
20 years. I don't know too many other guys who've been doing that. So.
Todd,
Yeah.
I need to be keeping mindful of time.
Yes.
Because we have told everyone that this is only until 7. So, obviously, if you need to leave, by all means, this is casual. Get up and take off if you have something scheduled after this.
Regarding the in-floor, I've heard where there's been passive houses in more mild climates that have never used them. They've installed them at a great cost, and it's so much overkill that they don't need them. Here, different climate. So
they train their inhabitants to wear shoes?
Or go to services that don't. Any questions?
Sorry, go ahead. I just want to be Florian.
Go ahead.
Oh, right.
Florian, you want to move on up?
Sure.
Or down? Over?
5 minutes.
I got a hall pass, buddy.
Okay, so quickly, Florian, if you can talk a little about energy modeling. Florian is the Vice President and Head of Product Development for Zola Windows. He consults clients on a variety of technical aspects of the project and oversees product development. Florian was born and raised in Düsseldorf, Germany, and received his architectural training at DGH in Zurich, Switzerland, and founded the University of New York City. Florian brings a broad technical knowledge of window design. Before founding Zola Windows, Florian had the opportunity to work on a wide variety of architectural projects, both large-scale commercial buildings such as the Public Library and customers. This experience includes work at Rem Koolhaas office, Rem Metropolitan Architecture, Rotterdam, S. Schaap Architects, in New York, and Zeiss, design in San Francisco. He's gained AP and certified passive house consultant and certified passive house. So, started.
Well, I'm glad that Todd got you the hopes of that I talk too much about energy modeling, but actually if I would start doing that, I would talk for the next 2 weeks here, trying to explain that damn passive house modeling software to you. So I'll skip that. The main message is a basic version of that we're going to do for you. So not many people in Steamboat know this, by the way. The pictures that are going to cycle in the background are all houses that are either passive houses in Colorado, either certified or designed fully to the standard, and they simply didn't want to spend the money on the certification, so they are all real passive houses. Anyway, so I was an architect back then in California, and I was kind of frustrated with windows I was buying for my clients, so I started this window buying cooperative in Europe. And then in 2011, some passive house folks in Denver met me on the street and asked if I would sell them windows. Okay. And then the guy said, like, actually, I have a friend who would really. I was like, okay, why don't here's my friend. Well, that friend turned out to buy $100,000 worth of windows for me the next week. As such, Zola Windows was born, which is now Steamboat Springs based. We have 6 staff in Steamboat Springs, and we are now actually the largest non-domestic supplier of passive house windows in the United States. This is Josh here, who's one of our project managers, and Evan, who's also a certified passive house consultant, and our senior project manager. We also employ 2 certified passive house builders, which train our customers on install. And if you want to look at a window, there's one somewhere. Yeah. But that's kind of unimportant. Let's get back to the pictures because I talked too soon. Anyway. What this is about, I was kind of thinking of what we can do locally to help get passive house or near passive house forward. I understand that many of you are probably thinking like, oh, passive house, that's way too extreme, let's go part of the way. And that's probably, in many cases that's a good idea, although I do want to say it is doable even here if you're on the right lots and if you happen to build large houses. Erik said, like, well, ROI is pretty long-term for it, and it's true. Pretty much any passive house I know that's over 5,000 square foot was sold by the comfort argument rather than the ROI argument. However, in Steamboat, if you have a wide open site, and if you're on propane, it pays off pretty good.
The ROI is there, yeah.
Okay.
With propane.
If you're on natural gas, the ROI is longer. But on propane, it's pretty damn quick. The second thing, everyone is so worried about how will I ever reach the ACH 0.6. And I'm glad to hear that someone said 0.07, and we hear these numbers that exceeded tenfold around the country again and again from builders, not on the first try, but on the second or third house that's going there. A lot of the builders we work with are very scared of the 0.6 the first time around, and they do 0.3 every time afterwards. It's doable, Obviously, don't sign a contract the first time that you're managing. But try first, okay? Even 1.0 is great, and it's so much better than any other standard building. Anyway, we were thinking, how can we help with the process of passive houses that are of high performances that are not quite going for the standard? And in our opinion, what's kind of missing is someone who can guide you to, where it's best to spend the money, because a balanced envelope and a balanced system is really, really important. It doesn't help to put in, an R50 wall, but then have a giant thermal break at the footer because you didn't pull the insulation around. Things need to be balanced to work. Otherwise, you're throwing money out of the window by, making a giant wall in one area and not in the other, or having weak links somewhere else. For me, the big thing when I got into passive house and had the passive house consultants training, like I spent way too much time of my life wasting on energy software, different types of it. Most of them have some sort of flaw or are not quite balanced. I think the great thing about passive house energy software is it's a really, really balanced approach, and it tells you where to put your money. Okay? Alone for that, I would argue it's worth to hire a passive house consultant on every project just for them to tell you, how to balance your project. Now I understand that not every project wants to shell out the $2,000, $3,000, $4,000 that it would cost for someone to get involved.
That might be low.
That might be low. Well, for full certification, well, we work with some
Full certification.
For full certification, you're higher than that.
You're
but,
right.
For an initial modeling, you're looking at 1,500 and up.
Yeah.
So anyway, what Zola is going to do is we are going to, for new construction in Broward County, sorry, it has to be new construction because we're not very good at remodels yet. Retrofit. Okay. We're going to use Woofy Passive, which is the main passive house software developed by the Fraunhofer Institute in Germany. That's from the guys who brought us the MP3. It's a pretty smart piece of software. We're going to use that for free to model your house. And then generate a passive house energy cost. So this is a sample we did for a Steamboat client just a few weeks back. It's a house that's being constructed on Anglers Drive. Erik would say it has too many corners. But that's how it is, and we're not going to bug you about that. So the great thing is with Woofy Passive, we get a nice output that you can take to your clients that we can discuss through about what it really means, where the energy is lost. Again, that's usually something we would retail for $1,500 and above. It's free for new construction in Broward County. The only thing we ask for is that we get a meeting together with the architect and the contractor if they're already decided. So that, it's a big house. It's a big house this year.
Enclosed volume 103,000 cubic feet.
Yes. The only thing we ask for is that we get a meeting together either at our showroom on Hilltop Parkway or at the architect's office just to discuss your options. And we'll make several suggestions about where are the weak points in your envelope and how to improve some details of that. Okay. We are not going to be pushy for buying our windows. Okay, that's not what it's about. We essentially want to provide a service so you can value better which way to go and where to spend the money. So we'll be hopeful that, hopefully all, but maybe at least half of new construction comes by and lets us calculate for you so that we can give you some advice on that. Thank you.
Very good.
Q&A?
Yeah, questions? Questions?
I just have a question for you, Todd. Of the passive house projects that you've been involved in all throughout Colorado, what percentage of them would you say are utilizing stiff construction versus the sort of hybrid type of systems?
Actually, not many. When it comes to the SIPs, they are effective, but they're more expensive. So, yeah, not many.
Can I chime in on that?
Sure.
So, since we consult nationwide about 200 to 300 passive house or close to passive house projects, and if I take out from that builders who are doing or architects who are doing it the first time, the predominant way of construction currently around the U.S. is 2x4 or 2x6 construction with foam on the outside.
Oh,
what I see.
Yeah. So
6 inches of foam or 5 inches of foam, something like that.
Yeah.
So I see most in repeat passive or near passive house buildings.
5 inches of foam on the 2x4 or 2x6?
On the outside, which that would not get you to passive house standard in Steamboat Springs, but it would get you pretty damn close. Yeah, in Steamboat, by the way, I'm the punch bag for that slow construction on Amethyst Drive. That's my house too. I didn't have time to take care of that, but that one is calculated to exceed passive house standard by, it uses about half the energy that passive house standard would allow me. At the moment, it uses no energy because that's impossible.
There's a foundation.
There's a
foundation.
Exactly. So, for that house to reach passive house standard, you need about 8 inches of foam on the outside. But, hey, it would be damn close with fire, and that's really doable.
What's up with the hay bales and all that stuff nowadays?
There's a guy in the Front Range, Brian Fuentes, is doing a fair amount of hay bale. They're straw bale, right? Straw bale. Thank you. And there's actually a presentation coming to Boulder February 13th, Friday, 6 p.m. If you're interested in heading down. He's a natural passive house builder out of Europe. His name is Bjorn something. Bjorn Shitable. Yeah, right. Anyway, it's possible. It requires probably more insulation beyond just the straw bale, depending on your climate zone.
I mean, Brian Fuentes, who has a passive house, straw bale passive house in the front range, he called me this morning and he said during the cold snap that we had a few weeks ago where we had -30 here, Boulder had -15, the coldest day, coldest point in his passive house was 62 degrees with the heat off. He overdid it a little bit.
But he also added additional insulation to his exterior.
Not in the straw bale parts, though. I mean, it's true that the basement is built not in straw bale.
I believe you might want to ask him. I'm
Okay.
not positive. Yeah, I think there's some extra insulation on his north side.
I think the straw bale approach is admirable, and I'd like to give I'm somehow fascinated with the idea of something that it doesn't rely on the embodied energy of petrochemical products to surround your house, and I think there is a future in that, but it is a lot more labor intensive and the labor factor would probably move the prices north quite a bit.
Well, and I've heard straw bale being considered carbon positive. Is that the way?
Yeah, because well, a
Just
very smart
carbon
guy.
sequestering.
A very smart guy once told me that I'm either too poor or too rich for straw bale construction. Meaning either you're doing it all yourself and it's a great way to do it, or
Well, and Brian often brings in his client and their children because it's great fun putting mud on the wall. So he'll have the kids involved in stuccoing, if you will, mudding the walls.
Just a quick question on windows. A lot of clients are asking for window walls, which are lift and slide, or like a nano wall system where it's all bi-folding. Do you guys have solutions for those?
Yeah.
Is that something that you say, oh, those are so inefficient, we can't put that in the calculator?
We both do. Florian and I compete.
we both work for, we're representing different companies here, but either of us have good solutions for that. The Amethyst house that's going to go up, I promise, this summer, has 5 lift slide doors that are up to 30 foot wide and 11 foot high, as well as folding window walls. And there's plenty of certified passive houses around the country using that. I mean, yes, that's the trick. Bigger glass. And actually, in a passive house, bigger glass is more efficient because the frame is the inefficient part of the window. No matter, even if I tell you the greatest window frame I've ever developed, the frame is still the crappiest part of your house.
Some rules of thumb on fenestration, glazing glass, is fewer operable if possible, because fixed windows perform better than operable windows. With an operable window, you have not only a frame, but you also have a sash. So you have more wood or frame material, which performs worse. Generally, high-performance windows are anywhere from R8 to R13 at the center of the glass, better than a 2x4 wall. So good glazing actually performs better than the center where there's insulation than a 2x4 wall.
What's the R value of a 2x4?
Arguably 11 or 12.
The wall assembly you're talking about.
Yeah, I'm
Insulated
saying,
wall.
yeah, just the wood part, which is the least efficient part of it.
Right.
Yeah,
Between
3.5 on the wood part.
The wood part's 3.5?
Yeah.
4.
So that is actually, well, the 2x4 is 3.5 inches. Wood is
1.0 per inch on wood.
But
then you have the finished material.
It's actually one of the reasons why I came up with this idea that I really would like to do energy modeling here, because there's so much, sales of and thinking of how walls perform, how they really perform very differently in real life. I bought a house that I currently live in up on Sky Valley Drive, wonderfully built, probably, best practices home. I asked the builder, like, oh, so what kind of R value have in the walls? Well, they are R40 walls. I'm like, what do you have in the walls? Well, they have 2x6s with the R7 closed cell spray foam. It's like, okay, that's true. The manufacturer of that spray foam claims R7 an inch by 6 inches thickness would in theory give you R42. But first of all, it's only 5.5. Second of all, first time I opened the door, on the 5.5, only 3.5 I actually filled, and there's a 2-inch air cavity back because you don't fill with closed cell spray foam all the way. And you have to take the stub penalty in between. So really, you're more like at R18.
When you look at the overall assembly with the stud.
So that's why we want to model it for you so you know.
So there's nominal insulative value, and then there's effective insulative value. So when you look at that assembly, he's right. It's like R18. It's not 42 by any means.
Now I'm going to, just to respect your time, these guys are going to be here for a while. If you want to come and ask them questions, please do. But thank you for coming.